Okay, started my recording a little bit late, but we are just reviewing some things for simplifying zero and negative exponents before we move on to a new content, scientific notation. And if a fraction is raised to a negative exponent, we flip the fraction and make the exponent positive. I've not graded your test for Wednesday. I will get them graded tonight in the grade book. Remember, I told you to do better on this test. I replaced your mid-chapter 7, 6 test grade with a better grade, so I will do all that tonight. Progress reports come out tomorrow. Well, I don't know if they come out tomorrow, but the grade at the end of the day tomorrow is what will come out in your progress report, so maybe they come out on Thursday, I'm not quite sure. Y'all caught up with me? Cole?
So x over y power negative 2 equals y over x to the power 2?
No, so it's only if the entire fraction is raised. So get that parentheses. It's a good question. So Cole's question is a good clarifying question, so let's clarify it. So if you have x to y to the negative second power, that whole fraction is not raised to the negative second power, so that would be x y squared. But if you had x over y raised to the negative second power, that would be y over x raised to the second power, which would be y squared over x squared. Make sense? So that's the difference. So the whole fraction has to be raised to the negative power in order for you to flip it. Make sense, Brandon? Okay. Great question, Cole. Cole had 2 great questions today. Caught up with me? Okay. So here's what we're going to do. Because I know some of you have started this chapter out working hard and may still be a little bit confused. Some of you have started out this chapter maybe not working so hard, but also maybe still somewhat confused. So I'm going to try, we're going to do some problems together. In fact, we're going to do like the even problems from this worksheet together, and I've decided the format I had it on first period did not work great, so I'm going to give myself more work room. Oh, yeah, that's what I was going to do, but it's too late. Okay, make it bigger. Okay. We are going to do literally the even problems on another worksheet. It looks very much like the two that we've done for this unit already. The directions here say for us to simplify. That's what we're going to do. So 10 to the negative fourth power. 10 to the negative fourth power. The negative 4 indicates what? That negative power, exponent of negative 4 indicates what to us? What do you think, Sarah? What does that tell us? So Akira said 10 times 4, but you put the 1 over it. Oh, 10 times itself, 4 times, and then you put the 1 over it, right? Swan? Yes, you guys are writing this, all of these, so these are going to be, we're going to do 2 through 16. So, basically Akira said that it indicates it's a fraction, because she put 1 over, right? So anytime we see a negative exponent, we should know it's going to be a fraction, so we can start by putting it over 1. And then we look at any negative exponents. If they're in the top of the fraction, they get moved to the bottom of the fraction. So in this case, 10 to the negative fourth is in the top of the fraction, so now we move to the bottom and make it positive. If there's nothing left up top, you put a 1 up there. What is anything raised to the 0 power? What is anything raised to the 0 power, Nicholas? 1. So 1.13.7 raised to the 0 power is 1.
That's actually not true.
Except for 0, my bad.
No, I mean like for a negative number, it's like negative 15 was raised to 0 power. But you said 4, it's not 1, it's negative.
True. So we really would read that as the opposite of 15 raised to 0 power. You're right. So if that were a negative 113.7, so everything, we just have to make sure how we are reading that is a little bit different than we're used to reading it. You're exactly right, Cole. So we're writing, if you didn't write that one already, make sure you wrote it. We're moving on to example 6. We're calling it examples. It really is just another worksheet. We're working the even ones together. Nicholas, you got this one written? 3 to the negative third power divided by p. What's the exponent on p if we don't see it, Naya? What's the exponent on p if we don't see it, Jaden? If you don't see the exponent on a number, what is it? Or a variable? So if I have 3, what's the exponent on 3 if you don't see 1? 1, that's right, 1. So 3 is the same as 3 to the first power. Any other exponent you have to put up there. If you don't see an x, it's kind of like a coefficient. If we had x, we have to know that that's equal to 1x, right? So it's the same kind of idea. So this is p to the first power. That's a positive exponent. So we leave that where it is. What are we going to do to 3 to the negative third power, Lee? Sorry? Let's go back here. So if the negative exponents are in the top, we move them to the bottom. If they're in the bottom, we move them to the top. We just put that in our notes. So is the negative exponent in the top or the bottom, Lee? Top. So where are we going to move it to? Do not know what has happened here. So we're going to move it to the bottom. I'm going to try to figure out a way to get my worksheet bigger again. All right, we're going to go. It's not quite big enough, is it? Huh. All right, then. That's annoying. All right, I'll just write them bigger. So this is 6, 3 to the negative third power over p. That's example 6. So we're going to leave the p in the bottom and move the negative exponent to the bottom. I put that constant, Danielle, sit up and look at the board, honey. I'm going to put the number instead of the variable because that's going to be the coefficient. We move it from the top to the bottom. We switch the sign. What do we put in the top if we don't have anything left? 1. And now 3 to the third power, 3, y to the x button, 3 equals, will tell us that's 1 divided by 27t. All right, example 8. -7/8, all raised to the negative second power. So this is one of those problems that the entire fraction is raised to the negative power. So we're going to flip the entire fraction, still keeps the sign, but we switch the negative to a positive. And now because this is in the parentheses, I'm going to move the negative. You can move the negative to the top or the bottom. I'm going to move the negative to the top. So it's -8 squared divided by 7 squared. So we rewrite this fraction, squaring the top and then squaring the bottom. So 8 positive negative button, x squared button, calculate that's 64, and 7 squared is 49. Y'all know there's an x squared button on there, right? See, if it's just squared, you don't have to use the y of x. You can just use the x squared button. So that would be example 8. Example 10. Note the parentheses here, and that's the difference. -9.7 raised to the 0 power, because those parentheses are around the negative sign, that's when we know it's 1. If there's no parentheses around that negative and the number, then it would be the opposite, right? Like the example we did at the beginning of class. I do know it's confusing. It is not lost on me that it's confusing. Any questions on example 10? So the next example, -2r s negative fifth power. What is the exponent on -2, Naya? Sorry? What's the exponent on -2 if you don't see it? Right. What's the exponent on r, Anson? 1. So these both have positive exponents. The negative exponent indicates it's a fraction, so we're going to put it over 1. We only move negative exponents. So these two factors with the positive exponent, they stay where they are. They're in the top, we leave them in the top. This has a negative exponent, so we move it from the top to the bottom. Does that make sense, Keishan? Does that make sense, Lee? Does that make sense, Jeremiah? Yes? The next example, 5a divided by 3b, all raised to the -2 power. The entire fraction is in the parentheses. So what are we going to do, Annabelle? Danielle? Flip it. So we're going to take the 5a and 3b and switch their spots. So it'll be 3b over 5a. So what's the exponent going to be here, Danielle? +2. Very good. So now we are going to distribute that 3b squared, 5a squared. So that's 3 squared b squared, 5 squared, forgot my parentheses there, 5 squared a squared. So 3 squared is 9, the b squared stays the same. 5 squared is 25, the a squared stays the same. Does that make sense, Jacory? Example 16. 2 to the -3rd power divided by n to the 0 power, n to the -1 power. What is m to the 0 power, Jeremiah? What's m to the 0 power? So anything to the 0 power unless it's a negative without parentheses. Jacoy? 1. Yeah, so that's going to be 1. So the negative gets moved to the bottom. This negative gets moved to the top. Does that make sense, Anson? So since it's a negative, we have to move it, and that makes it a positive. Since this is a negative, we have to move it, and that makes it into the positive 1. This is 1 in the bottom. 1 times 2 to the 3rd power, that doesn't change. So we're going to leave that as n. And then 2 y to the x button 3 equals 8. Any questions, Kendall? All right, example 18. -3 to the -3rd power. And let's go ahead and put our parentheses there, even though it doesn't have it, because if it doesn't have it, we have to rewrite it with that or remind ourselves of what it is. So it's already a fraction. What is the exponent on u, to Corey? What's the exponent on the u? Positive 1, right? So positive exponents we leave where they are. So the u is going to stay in the bottom. -3, so we can actually just go ahead and push that negative sign out here too and not worry about it anymore. We're going to put 3 to the positive 3rd power in the bottom. We're going to put it in front of the u because that's going to be a coefficient. The v to the -2 power, the only way to make that a positive 2 is to move it to the top. So we have v squared, 3 to the 3rd power, 27u. Any questions? So that is a recap. We've done that this is our 3rd day on that, all right? So today we're about to start talking about scientific notation, which is something that you guys should have seen before. 7th, 8th grade math, maybe even Algebra 1A, but definitely 7th and 8th grade math. Probably a science class here and there as well. Yeah. That doesn't mean that you have to like it. It just means it should be familiar, right? And we're going to go ahead and take some notes on it. You guys caught up with me? Yes? Okay. So scientific notation is a form of writing really small or really large numbers as a factor of 10. So that's what you guys are writing right now. I'm actually going to make that right here. So the form should be a number, some number, and that number has between 0 and 10 times 10 to a power, right? So that's the form that makes it scientific notation. When we write it in what we would consider a regular form, that's called standard form, right? So normally we write numbers in standard form, but if we've got a super huge number or a super small number, sometimes the only way to write it would be in a notation like this because you could never get it on a piece of paper. so many digits or so many decimal places. So as an example, I got two examples here. So 3 times 10 to the third power, which that's not a humongous number, but I want you to see this number 3 is between 0 and 10. It's times 10 to the third power. And if that was written in standard form, 10 to the third power is 1,000 times 3, so that would be 3,000. Now, just like all the other expressions and values we've been looking at, if there's a negative exponent, it indicates that this is going to be a fraction. In this case, we're actually going to write the fraction as a decimal. Remember, a fraction and a decimal are the same thing, right? 1/2 is the decimal point 5, right? So this is a fraction, but we're going to write it in decimal form. So if you were to write this as a fraction, this would be 3 over 1 times 10 to the negative third power. You'd move that negative 10 to the negative third power into the denominator, and you would see that that is actually 0.003. So these are examples of numbers written in scientific notation. So we are going to go ahead now and put in our notes, negative exponents are numbers less than 1, positive exponents are greater than 1. Negative exponents, on the 10 would make it less than 1. Negative exponent on the base of 10, or positive exponents on the base of 10 are greater than 1. These technically aren't in standard or in scientific notation right now, so we're going to rewrite them in scientific notation. That is the same as 1 times 10 to the negative first power. Does that make sense? Now, if we wanted to write that in standard form, so standard form would be, so this in scientific notation, standard form would be 1 over 10, or 0.1 as a decimal. Does that make sense, Annabelle? All right, this one, not technically written in scientific notation either, so we're going to write it in scientific notation. A number between 0 and 10. Remember, 1 times any number is just that number itself. So if we write this in standard form, it's 1 times 10 to the second power. What's 10 to the second power equal? It's 10 times 10. 100, right? So that standard form would be 100. Alright, so let's look at this example. So, is this number written in scientific notation? So is this number between 0 and 10? And is it times 10 to some power? So that one is in scientific notation. Okay? If we wanted to write that in standard form, it's 8 times 10 squared. So standard form is 800. Does that make sense? Standard form here, there's a couple ways to do it, and obviously your calculator is going to be the easiest way to do this. If they give you a number in standard form, You can literally enter it in on your calculator and it will give you the decimal version. The shortcut, if you don't want to use your calculator, look at the decimal place. If the decimal place is not there, we know it goes there. We need to move that back 1, 2, 3 places, and so that would equal 0.003. I think if you don't know how to do that at this point, let's not worry about it, because you get to use your calculator. So I will tell you, 3 times 10 y to the x button, 3 positive negative button equals. That's how you can do this one on the calculator. So what do you get when you do that on your calculator? So 3 times 10 y to the x button, 3 positive negative button equals, what did you get, Brandon? Did you do it on the calculator, Cole? What'd you get? You can't use that calculator, so might as well practice the other one. What'd you get, Sean? Very good. You should have gotten the same thing as I got up here using the shortcut. I'm going to suggest, unless you're super comfortable with this shortcut way, let's just use the calculator because you guys always get to use the calculator, okay? All right, so these were in scientific notation, and we wrote them in standard form. Now we have this decimal, this 400, these are written in standard form. Standard form is just the normal way to write numbers, the normal way we would do that. I'm going to move these down some. So if we're going to write these in standard notation, scientific notation, give yourself a blank, some number times 10 raised to some power. Okay? So far, so good? Make sense, Naya? So we're going to fill in the blank. So now we look at our number. Go to where the decimal point is. If I move to the right one place, well, let's look at it this way. If I move this to the left, I'm not getting any closer to the value of between 0 and 10, right? So this number has to be between 0 and 10. Right now it's, actually it's not 0 and 10. We all change our notes. It's between 1 and 10. It might be between 1 and 10. So if we move it to the left, it stays less than 1. If we move it to the right, it's 0.4. That's not big enough. If we move to the right 2 times, now that's a 4. Right? If we move it 2 times, and it started out as less than 1, we know it's going to be a negative 2. So that's what our exponent is going to be. So it's 4 times 10 to the negative 2 power. That indicates that it's a number less than 1, right? Any questions on this example? All right, so if we're writing 400 in standard scientific notation, rather, it's going to be some number times 10 to some power, right? So now the decimal point is here, even though we don't see it. That number is too big. It's got to be between 1 and 10. If I move it back 1, it's at 40. If I move it back 2, now it's at 4. So if I moved it 2 places to the left, that's a positive 2. 2 right, it's a negative 2. 2 left is a positive 2. So I don't really expect you to remember it that way. Just move it until you get to the place you need to be. Not yet. We're not quite done. Y'all caught up with me? Okay. So now we are going to do one of the problems from your homework because the directions are something different. The directions say evaluate each expression for the second group of problems. So we are going to do number 23 together, so you know how to do it. But first, you're going to underline evaluate and make yourself a note somewhere above it. So you're underlining evaluate, and you're going to write that means to plug in for. Means to plug in and simplify. That's what the word evaluate means there. We're going to do one of your problems together so you have an example of it. We're going to do 23 together. 4a squared b to the negative 2 c cubed. So if you're finished reading the directions for that section, it says evaluate each expression for a equals negative 4, b equals 3, and c equals 2. That just means for a we plug in negative 4, for b we plug in 3, and for c we plug in 2. So that's what we're going to do. Remember that's 4 times a squared, so a is negative 4 squared, times b, because b is 3, negative 2 squared, times c cubed, c is 2. Y'all with me? So this was the problem. They told us in the directions that a equals negative 4, b equals 3, and c equals 2. So we plugged those in. We've replaced the variables with those values. Does that make sense, Hayden? All right, and now we've got this negative exponent. I think we start by moving that to the bottom. So let's move that to the bottom. And now what we have is negative 4 squared times 2 cubed. And the negative is inside the parentheses, so that's going to be 16 times 8 divided by 9. Times 28 divided by 9. And I think that is already simplified. Any questions? Yes, you can submit your notes. And you can copy, well, you should have done number 23 on your worksheet, but if you put it in your notes, you could go ahead and copy it on your worksheet. We've got a few minutes, so we're not packing up yet. You should be able to do a couple of the problems before we go. You scan and submit your notes. You can do that if you like. Yes. Too late now, Andy. Sorry. Take the last 10 minutes.